That looks good. I'm waiting for the live stream to catch up to make sure everything sounds good. And I don't know if you guys can hear that, but there's some construction going on right outside the window. So if you hear like chainsaws or somebody being like, oh, hey, move that beam, that's what it is. And we'll just say that camp is being renovated. And that's what the noises are. Welcome, campers. It's the very last week of SQL Summer Camp. I hope you are excited. We are going to be working on stuff that's a little bit more advanced, but also super powerful. Oh my God, they're chainsawing again. Super powerful. Just going to make sure this is pointed right at me. And that I use all the time in my work. So, and I think I mentioned it a couple times, I do a lot of work with SQL as part of my day-to-day job. Like, I think most professional data scientists, or even people who aren't data scientists and work with data a lot, that's in databases. So, Jiminy Cricket. So the lessons that we're doing are actually from the Advanced SQL course. Man, I hope you guys can't hear that. And we are going to be starting with lesson 1 here, joins and unions. And you'll notice that there are actually 4 lessons, even though it's a 3-day event. You don't have to finish the 4th lesson for the I'm going to die. No, I'm fine. It's just very loud. You don't have to finish the 4th lesson to get the certificate. You should be fine without it. But that'll be, I'll do like a little sneaky extra stream at the end so that you can learn a little bit more about optimization. But today, we're learning about joins and unions. So when we first started in our very first sort of intro video, the first thing that we talked about was how databases and relational databases are like a collection of spreadsheets, right? Where each spreadsheet is a table. And the thing that makes them relational is, I think that the thing that makes them relational is that there are relationships between the different tables. So you could think about, for example, if you have an e-commerce website. I've been using that as an example a lot because I think most people have interacted with some sort of online store at some point. So if you are on an e-commerce website, you might have a database that has several tables. Maybe one is a list of products that you sell. Maybe one is a list of customers that have created an account. And there might be another table in your database that is orders. And inside each of those orders, you might have information about the customer, but you're probably not going to actually have the customer's name, address, and order history and all of the other information that you're storing about the customers. You'll probably just have one column that says something like customer ID that has a value in it that uniquely identifies a row in the customer table. So we haven't talked a whole bunch about keys, but the idea with a key is that in a given table, every row has a unique identifier or key. Here we're calling them IDs. And the reason that you want them to be unique is so that you can refer to them from other tables. So in our hypothetical orders example, we might have a way of referring back to customer. We might also have, underneath the things that you've ordered, you might have some sort of nested data structure with all of the individual items. And you're probably, again, not going to have the complete information on the item, like the picture and like the full specification. You'll probably just have one ID or key that refers back to the item in a separate table. So if you want to learn more about that item, you need to go to that table. Jake says, I said I was not going to answer questions until 30 minutes too, but this is a very relevant question. Why do you want many different tables? So a big reason is speed. So if I am, on my website, I'm trying to load, I don't know, I'm trying to think of a good example where speed is important. This is more on the software engineering side of things, and I just sort of tend to come upon existing databases that I need to work with that were built by people who build databases. But lots of small tables are generally faster to fetch and run operations over. One really big table is much harder. I think there's also a little bit of a security component, because if you have some tables with sensitive information and other tables that don't have a sensitive information, and people can like access one of those tables somehow through hacking, I don't know, I'm not a security person, having them more distributed is better. When I was learning about databases, I was taught many small modular units, and that's just what I was taught. Also, it makes it a little bit easier if you need to add additional tables in the future, right? So instead of, if you have one table, if you wanted to add some new piece of information on every single product, instead of having to update your enormous table that has everything you've ever done in it, you just update the product table with that additional information, and you just refactor that one. So lots of reasons. I think those are the most common ones. All these recordings, all of the recordings are in I said I wasn't going to answer questions. I'm going to need to like cover this window so I can't see them. All of the recordings are on the Kaggle YouTube page under playlists, under SQL Summer Camp. And I think if you click on the header image in the email, it should also send you there, if I did it right. Okay, so we've talked about how you have lots of different tables, you have lots of different references to other tables within the tables, and we talked about inner join, which is where all of the things that exist in both tables, you take a set of those and you create a new table out of it containing all the information. But there are other types of joins. So here's an example of the inner join where we're getting the owner name and the pet name from these two tables, where we are joining based on the pet ID. So you can see each pet here has a unique ID or key, and these keys are used in this other table. They're foreign keys, if you've heard that term. And we are just saying, hey, for every row where the pet ID exists in both the owner's table and pets table, get me all of both of those tables. So it's like is there a set diagram in here? Here we go. So it's the, conjunct. It's been a minute since I took set theory. It's the overlapping set. The other types of joins that you might want to do, and there's a couple different ones. So one of them is left join. So in a left join, your first table is your left table and your second table is your right table, just by, convention, I guess, because the SQL assumes that you read language left to right, right? Yeah, left to right, the way that English is written, not like bottom to top, or actually that's extremely weird, top to bottom or right to left. But maybe we want to get the information on all of the owners, even the ones who don't have a pet. So maybe we're trying to send out a mailer about an event, and we think that even if, say, your pet passed, it's still relevant for you, and we want to send it out to you. So in order to do that, we would do a left join. And you can see that we have information from the right table, the left table. In this case, it's this one, which is on the left. There we go. The left table, which is on the left, the owner's table. And we also have null here. So this is where when we asked for the information about the pet of Veronica Dunn, you can see no pet ID, so it's not matching to anything, so we just get null back. So null is like not an enter or empty. And then a full join. So you can also do a right join, which is the opposite. So a right join here would get us instead of this row with Veronica Dunn and null, we'd get this row with null and Maisie right here. I think people tend to do left joins more than right joins because generally you do the more complex table first. And I don't think there's like a parsing reason for it. I think that's just convention. And then a full join, oh, and I do see a table. Fazil says, is left join the same as the whole left table? No, because if we look at the left table up here, you can see that we have information on the name of the owner and the pet ID, but we don't have the pet name. So what the left join is getting us is this additional information in our right table, but we're also getting all of the rows in the left table. Sorry, I said I wasn't going to look at questions. You know what, I'm going to drag. One sec. I'm going to drag another window over the YouTube window so I can't see y'all's questions until I'm actually ready to answer them. Okay. The other type of join is a full join, and a full join gets you all the tables from both rows. And here you can see for all of these, we're only selecting two columns. We're selecting the owner name and the pet name column. If you selected all of the columns, your full join table would have all of the columns from all of the tables you joined. So if we did a full join here, so you can see, first of all, that there's a name conflict. So I think BigQuery will automatically go ID underscore pets and then ID underscore owners, I'm fairly sure. And you can see that we have a conflict in this field. So it's this one's called name, this one's called name. So we get name underscore owners, name underscore pets. Age, these are human ages, so age underscore owners, age underscore pets, and then pet ID and then animals. So if we did a full join here, we would get all of these columns except for the one that we joined on. So this one here, pet ID that corresponds to this ID, would be merged into a single row. So I guess all but one column. That's where I was with that thought. I'm done. I'm done with that thought. The other thing you'll get is all of the rows. So if you want to make a really big table that crashes your server, doing a full join and select star is a great way to do that. And I am being a little bit sarcastic. You probably don't want to do that. So full joins are worth being a little bit delicate, a little bit cautious around. So those are joins. But what if you don't actually need a bunch of information in different columns? You just have some sort of data that is comparable that's in the columns of many different tables. I forgot the word table. Well, another little sip of tea. I think I need some more caffeine. So the way that you would handle that, let me actually come up with an example. So let's say we want to have just a list of all of the names. So people names, pet names, everybody's names. Maybe we're doing like a fun collage in the office where everybody's name gets written up and you can like, oh, there's my name. Oh, there's my pet's name. I feel like that would be a breach of privacy, but let's imagine that it's not and that this is something that everyone has opted into. So if we wanted to get all of this similar information, so you'll notice it's the same data type, names or strings, or if we wanted to get all of, let's say the weights of everybody, I don't know why you'd have human weights and animal weights in the same database. That seems a little bit weird. Let's say we are botanists and we have a database of flowers and each flower is in a separate table, and we have as part of our information the RGB color signature of a photo that we took of the flower of like the middle of one of the petals or whatever, and we wanted to have information about all of the flower petal colors to see what was the most common. So there's a nice numeric example. We can get all of these types of informations and make a really long column using union. So here we have an example of an age union from these two columns. So these columns both have numeric values in them. These are integer numbers. If you try to do a union with two different types of data, I think this is one of those things that varies between flavors of SQL. I think sometimes it'll be coerced to the most general thing. So you'll get, like, if you have a string, it'll all be strings, and sometimes you'll get an error. So the difference between a what's this? A join. And a union is that a join, especially an inner join, adds columns where the columns are taken from different data sets, different tables in your database, and a union adds rows where the rows are information of the same type, again, taken from different tables. So if we wanted to do like an age union and also a name union to have names and ages together, we could do that because names is the same data type and age is the same data type. But one column is usually easiest. Okay, so let's work through an example so you can see how this works in code. And I am actually just going to... I'm just going to create a new kernel to work through this, new notebook, just to work through this together. Oh, and you will notice we have a new notebook launcher now. So I do want it to be Python. I do want it to be a notebook. You can turn your GPU on or off. If you were going to use your personal BigQuery account, you could enable it here, so you don't have to relaunch it. But I don't want to do any of that. I'm just going to create a notebook. And then the data set that we are using for this example is Hacker News from the BigQuery data set. So I'm going to add that data set. This is a public data set, but in order to query it, I need to have it added to... let me open this in a new tab really quick and make sure that this is a BigQuery data set and it's the one that I want. Yeah, it's a BigQuery data set. So you can see it says here. So adding this to my notebook gives me the permissions to read from this data set. So here we go. Little sip of tea. Let's just copy and paste this boilerplate code. So if you did the BQML workshop, we talked a little bit about the Jupyter magics for running BigQuery. You're welcome to do those. I'm going to stick with, for the Advanced SQL course, I'm going to stick with what we did in the Intro SQL course, and using this sort of like client, setting it all up this way. And we talked about that in the very first video and the very first notebook. So let's just run this boilerplate. I'm hitting Control Enter to run this cell. So we're creating a client that's like a little messenger that goes back and forth between us and BigQuery. We are giving it a reference to the Hacker News dataset, which is in the BigQuery public data project. And then we are fetching the data set. We're getting the comments table. So this is a table in the data set that has comments in it. And if you remember, there was a... Oh, I'm sorry, my headphones. And if you remember, there was a... I don't remember it off the top of my head anymore, but there are ways to see what tables are in your data set, so you can check that out. And then we're getting the table, and then we're just going to look at the first 5 rows of the table. And it's Python, so we're indexing from 0. And you can see that we have some information here. We have the ID, and I believe this is the comment ID. This 0, 1, 2, 3, 4 is the row index added by pandas. This is not specifically part of the data set. So this is the author of the post. The time that it was posted, again, I think this is in the Unix epoch. So this is the number of seconds since when that started. It's some date in like the 70s, well before I was born. And then we have the timestamp of the time that it was posted. We have the text of the comment. We have the parent, so comments are usually on something, on a post, on a different comment, whether it's deleted, whether it's dead, and then it's ranking. I don't know what ranking is. That's probably something specific to the Hacker News site. Maybe if there's multiple comments, it's the most upvoted one, but I don't know if they would index from 0 or 1 there. Anyway, that's what's in this comments data set. And you can see we have the exact same information here. But we're working on joins, so we need at least another table, and for that we're going to use the stories table. So This is creating a new reference, and you'll see it'll actually override our old reference, which is fine. These references and tables that we're using here are just a way for us to interact with the database really quickly and get some information. When we write the query and we send it in, we actually give BigQuery in the query the full path to everything that we're trying to look at. So it's okay that we've overwritten our table reference here. This isn't going to be used in the actual query. So in case you were worried. And you can see here is the stories table. So we have, again, a unique ID. You'll notice that these aren't sorted. They're probably sorted in the underlying database. Because of the way that BigQuery queries are optimized, they're sort of, they're multi-threaded and then they're shuffled. So you're not going to get results back in the same order unless your query has been cached. And your query will be cached for, I think, 24 hours after you run it. So if you run a query and then go do something else for a day, and then come back and rerun the query, you'll get the same results if the underlying database hasn't changed, but they'll be presented in a different order, which I know is a little bit, especially if you're used to working in more deterministic things where you always get the same results for the same input, can be a little bit surprising, but. Okay, and then we have the score. So this is the author of the story, the score, which is presumably upvotes. The time, again, in the Unix epoch, and then the time stamp. I don't know why we have both of those. That seems a little redundant. We do have both of those in both of these. Interesting. The title of the post, the story, the URL. So I think this is a way for people to share links. I don't really use Hacker News much. It seems like kind of a mean community. And then the text, so the information that they provide with the link, if it's deleted, if it's dead. Descendants, so this might be something with like a thread structure where there's a reply to a different comment maybe. And then again, the author, which looks to be the same as by here. So it looks to be maybe slightly redundant. But I suppose there might be situations where you could have a post by someone where the author is different. Maybe you can assign posts to somebody else once you make them. I, again, don't really know, but that's what's in the database. And if you're like, Rachel, why are you just sort of looking at the column titles and trying to figure out what's in there? That's a lot of professional data science. Yeah, sometimes you're lucky and people have like a beautifully documented database and they send you like a PDF and they're like, oh, here's all the columns, here's what's in them. And sometimes you get one of those, and it was very accurate at one point and isn't anymore, and the schema has changed dramatically, and yeah, that's just the way of it. So I think it's good practice to get into, to spend some time just like sitting down, looking at the database and figure out what you think is in there. And then it's always worthwhile to ask if you are not 100% sure once you've spent some time figuring it out on your own. All right, sorry, I got sidetracked. I'm very tired, and I get very easily sidetracked when I'm tired. All right, let's write a query. So this query here, and let me actually take it to the, I'm just copying and pasting. You wouldn't usually want to copy and paste, but I believe this is one of the ones, yeah, you see for the Learn courses in particular, we've removed the fork option. And we don't expect you to actually run the code in the notebooks. In the tutorial notebooks, we expect you to just sort of like look at it and read it and figure it out, and then actually run the code in the exercises. Which is why you can't fork them, which I know is a little bit frustrating if you expect to fork them. All right, so we have our query here. So we're using with as. You know right away we're going to be creating a common table expression. We're going to be creating like a little mini table that we can refer to further on. And what we are selecting is parent and count star, so count everything, as number of comments. So we've going to have two columns here, one called parent, one called number of comments. That is from the Hacker News. And this is going to be from, so you do need the whole address, BigQuery public data, Hacker News is the specific data set, and then comments is the specific title. And just to call these out because this is a point of confusion, these little guys here at the end, let me zoom in a little bit. These little guys here in the end are actually backticks. So they are not sort of like quotes that you would put around string, at least in English. They are, for me, this guy here. Nope, this guy here, right with the tilde key in the upper right-hand side of my keyboard. And I know keyboard layouts differ from country to country, but that's where it is for me. And then we're grouping by parent. So what we're looking for is the parent column, and then we're grouping by parent. So every row that has the same number for parent, because I believe the idea is a number, is going to be treated as a single group. And then within each of those groups, we're counting the number of rows as the number of columns. And then we're going to call that table C, so C for comment, or we could also call it number of comments. Generally, the bigger your query is and the more people are going to look at it, the more informative you want your variable names to be. And then we are also going to be getting some stuff from another table because we're doing joins. So we've got our common table expression with two columns, and who knows how many rows. And then we're going to do another one. And I'm actually just gonna just make it a little bit easier to follow along. Put little spaces in here. There we go. Just 'cause I think it's a little bit easier to see at a quick glance how many columns you have. So we're selecting ID as story ID. We're selecting by. We're selecting title. And those are all from SSS. You'll see S dot. The S dot means from the table. Dot means look inside that table, and then this is the name of the column. And where is S coming from? We didn't do anything called S. We did actually, so it's actually underneath here in the from portion of the query. So from BigQuery Public Data is the project, Hacker News is the data set, and then stories is the table as S. So we're actually giving this whole table a little pseudonym, little nom de sequel, S, and then we're going to use that to refer to it further up here. And there was some questions about this earlier. Hey, how can you refer to a variable name before you actually write it in the code? And the reason that you can is that SQL queries are not actually evaluated top to bottom in the order that you write it. They're evaluated in a different order. And there's some posts on the forums if you're interested in learning more about that. Anyway, so we are selecting story ID, by, and title. We are also selecting, you can see here, C. So C is this common table expression that we made up here. We didn't make it up. We have already created it. And from there, we are selecting the number of comments row, and you can see that number of comments here is one that we created and named. So we're selecting some columns from one data set. We're selecting one column from another data set. How do we know how to squanch them together? So we are interested in trying to get the number of comments on each story, right? And the parent ID here is actually the ID of the story. So if we look in the SID, story ID, as we have recalled it, column, that information is going to match up just like, woo, just like in here, the ID of the story is called parent over here, so we can match them one to one. In order to do that, we need to say what type, whoops, that's not going to work. We need to say what type of join we're doing. We're doing a left join, so we're going to get everything in the left table, and then the things that have parallels in the left table in the right table. And then we're going to join it on. So this says which specific column it is that we're interested in using. And we're going to use s.id. And we can't Unfortunately, we can't use story ID down here when we're talking about the join because it hasn't been, because the join is evaluated before the select. So if you specify something in select, you can't refer to it in the join, which it's confusing, but you can't. Just remember that. On story ID, and we're going to say, hey, the story ID column is the same as this other column that we created up here in our table C. We didn't actually create this column, called parent. So look for everything in the... Oh, this is a little bit backwards. Sorry. So the left join is actually the left on this side. So we're getting every story. And then we are, for every story, getting the number of comments. And if there are no comments, we're going to get null. So we're actually specifying the right table first in this case. And the left is the left in this particular line, which is this one, s.id. Sorry, I think I might have confused you. Hopefully I haven't. And then we're also going to do a little bit of extra filtering. We're going to say, hey, I don't want all of them. I only want the ones from New Year's Day on 2012 for some reason. Maybe you noticed that there were a weird discrepancy in the number of comments on the site on New Year's Day, and you're like, hey, that's not normal, even given what we know about New Year's. So let's try and figure out what's going on, and you're trying to get more information. So we are going to extract the date from this timestamp column, and then we are going to order by number of comments descending. So we're going to get the story with the most number of comments first, and then going down. So let's run this whole thing now that we've gone over it in just excruciating detail. And it's going to take a tiny bit longer to run. So in general, joins take the longest to run of any SQL queries because you're looking at a lot of things simultaneously and you're doing a lot of individual comparisons and you're trying to get a lot of information together. So if you are, especially if you're doing a full join, that can really gum up the works. All right, so you can see here we have the story ID, by, so the author, title, so this is the title of the story, and then the number of comments. So the top number of comments was Ask HN who is hiring, January 2012, and that had 154 comments. And then Ask HN freelancer, seeking freelancer, January, presumably 2012, 97 comments, and then so on and so forth by the number of comments. So that's joins. Let's talk about unions. So here we have an example. Oh, I zoomed too far down. I was like, we definitely ran that already. And I will leave checking the tail to make sure to zero as an exercise to the reader because I'm a little bit behind schedule. Oop, that is definitely the wrong cell, what I selected. I don't know why copying and pasting is so hard for me, but it is. All right, so what are we doing in this query? Here we just want to get all of the users who posted comments or stories on January 1st, 2014. So this is actually a different date. So we are going to select the by column from BigQuery public data. That's the project, Hacker News is the data set, comments is the table as C. So instead of putting this whole big thing in here .by, we are giving it a little alias, C, and then referring to it up here in the select clause. So we are selecting all of the authors where time is 2014-1-1. And then we are doing a union distinct. So distinct says, hey, I don't want any repeats. I want all of the unique values here. So if you're doing something like, I'm trying to think of an example where you wouldn't want it distinct. So if you were like looking at census data from a bunch of different countries and you were fortunate enough to have it in one SQL database and you wanted to find out the most common name in the world, like the most common first name, you probably wouldn't want to do a distinct because you'd also want information on the counts, right? So here we are taking the distinct ones. We are only looking at one instance per case, regardless of how many times it shows up. So even if you made 150 elements, you're only going to show up once when our query is output. And we are taking the union of this c.by column with this s.by, where this is from the stories. So in both cases, these are the authors. These are the authors of the comments. These are the authors of the stories. We're doing the same time filtering. So we're looking at ones that are specifically from January 1st, 2014. And then we're getting the set. That's probably easier. We're getting the set of names from authors and authors of stories and of comments. We haven't sorted or anything, so you can see here are the first 5, and they're not especially in any significant order. All right, so those are joins and unions, and I'm only a little bit over time, so let's go for questions. Going out. All right. Abhishek says, when joining multiple tables, if possible, start with the smallest table first, do inner joins before outer joins. Yeah, absolutely. You want to, I'm assuming this is in reference to somebody else's question. You want to get your data as small as possible, as quickly as possible, because when you do a join, you need to compare all of the possible combinations of your 2 data sets. So if you can imagine if we have, we're trying to join 2 rows in dataset A and 2 rows in dataset B, that's 4 comparisons. If we're trying to do tree, that's 9. So it scales pretty dramatically. And I believe that there are some fancy database tricks that make that faster and have fewer comparisons. And I just trust DBAs to know them and implement them. All right. Let's see. Kay is talking about the sort of canonical order of writing SQL queries. So from, where, group by, having, select, order by, limit. And joins, sorry, no, that's not the canonical order of writing. That's the execution order. I believe joins happen after having and before select. Don't quote me on that. This is where I'd Google it. All right. Other questions. It looks like mostly this is actually people answering other people's questions. So 10 out of 10, everybody. I'm just seeing lots of good discussion. Joins, other types of joins. Oh yeah, somebody mentioned that, I'm going to go to the forums next. Someone mentioned that this is similar to the concept of joins in pandas, which is absolutely true. If you're familiar with, I think the joins in R are implemented in the tidyverse, so you can also do inner joins and outer joins and left joins and right joins, etc. In R as well. So you can absolutely do these same sort of processes in Python or R. In general, it's going to be, if you have the same data set size, it will be slower to do a transformation in Python or R than it will be in SQL. SQL is just much faster for reasons that you can look up. Ugh. All right, let's check out the forums and answer questions there. Zuhair says, why result to data frame instead of to data frame? And I didn't say it with my voice, so it's hard for you to see. The question is, why am I doing this instead of it looks like you're asking about this. I believe this will give an error because it is not well, let's find out. So if you, actually, that's a good question. What is union result now? So the error was when we looked for the hood of it. Oh, I see. Okay, so what's happened is we have assigned this function to data frame to union result. So when you leave the parentheses, oh gosh, now we're getting into the part of Python syntax that I'm a little bit fuzzy on. That one part of Python syntax I'm a little bit fuzzy on. So when you leave all the parentheses, Python is like, oh, this is an attribute. And so it will not try to execute it as a function. And then you get errors when you try to do things with it. Let's see what happens if we just press union result. Oh, so you can see this is a bound method here. So instead of actually going and getting the data frame and running everything that's in the function, we've created a pointer. Oh, I don't know if it's a pointer. Maybe it's a pointer to a method. The short answer is that I'm following the documentation. I'm following the canonical example. All right. Other questions. Result set is not a data frame. Yeah, this should be a data frame. If you actually run the, so I believe result is returned as, well, actually, let's find out. I was gonna say, I think it might be Jason, but I don't know about that. Okay, I see. So it's actually returned to us as a row iterator as implemented in BigQuery. And so to get this row iterator to a handy Python data frame that we all know and love, we need to call, there we go, we need to call the function toDataFrame, and that will give us, I don't know why I printed out the whole thing, and that will give us the actual data frame instead of that row iterator object. And there are things that you can do with the row iterator object that they've sent you that are implemented in the BigQuery Python package, but I prefer data frames, personally. Andrew says, a union seems to always give a single column, so what should you do if you want to bring along other feature columns with the union? Let's try. All right, so here we have comments and stories. Let's go back up and look at these and think about something else that we could sorry, so I'm just thinking about it. Common limited unions in legacy SQL. Make uniting results very simple. That's not a union. We don't need to specify anything. It's just going to get union all. Oh, I see. So it looks like, is this specifically for BigQuery? Yeah, this is specifically for BigQuery. So it looks like here we have data sets. I don't know anything about this data set, but it looks like we have like books, and then we have different tables for each year. And in each table, we have information on the book identifier, the date, and the title. And you don't need to actually specify that it's union all as long as they are in the same format, right? So we could So if we have like different tables that have this columns that have the same name and information in them, you can just say from multiple tables, it'll get all those columns from all of those tables, and then it will concatenate them. So you'll get a one really long data frame with the relevant information from each of the tables you specify. And you may need to specify that you're using legacy SQL here, because I believe we've been using standard SQL instead of legacy SQL. Okay, yeah, so it looks like in standard SQL specifically, you need to say union all every time you grab the columns from the table. Be like, okay, and also join them to these other identical columns with different information in them, obviously, from this other table, and then join them on these other, sorry, not join, union them with, well, add them to the end of the data frame, these other columns that are also the same from this other data set. And unfortunately, I don't think we have any good, I don't think we have more than one, let's see. Oh, we might actually be able to do by and time. So let's really quickly figure out if we are, in fact, I don't need this cell anymore. Let's figure out if we are, in fact, doing regular SQL or legacy SQL. So let's select by and time, because I think those columns exist in both. And then we're going to do from, and in from we're going to pass in multiple tables. So we're going to do the stories one, and we're going to do the comments one. And let's also keep filtering by date, because that's a lot. That's a lot of data if we join the whole thing. Comments. All right. Is my syntax the same? Let me double check. Yes. All right. Let's see. Nope. Syntax error, unexpected keyword by. Oh. Noted. Okay, I think the problem here is actually that by is a reserved word in SQL, and it is here being used as a column name. So instead of time, let's use time TS and see if that works. Unrecognized a name S. Oh, yeah. That makes sense, because we are referring to an alias that we haven't actually made in that query. So let's fix that. All right. Column name, time TS is ambiguous. Okay, so it looks like we are using standard SQL and not legacy SQL. So in order to do a multi-column join, do we do extract at the beginning or the end? Let's do it at the beginning. And then union all. So we're going to do all of the stuff from the same thing. So we're getting the same columns, and they're the same data types. So that shouldn't be a problem, because we will have a problem if we try to join columns of different data types. And comments. It's taking a while. That's a good sign. Yeah, there we go. All right, and now we have one very long data frame that has the union all, so it's not the distinct. It's going to be all of the items that occur in time TS and time columns from Hacker News stories and Hacker News comments. Carlos said, would putting by in quotes or backticks have worked? Yeah, probably. Yeah. Oh, and Marco says for legacy use, you need to put the table names in square brackets. Good tip. But I'm pretty sure we are using standard SQL here and not legacy SQL. You may need to have your own project in order to enable legacy SQL in BigQuery. I don't know. I haven't played around with it that much. So maybe I'll do that today if I have a little extra time and post about it on the forums. And Abhishek points out that, yes, union all here does allow duplicates. So, true. All right. Unions must have the same number of columns and same type. Yes, that is true. If you try to mix types. Well, actually, let's try it out. Let's try it out. Pretty sure this won't work. Could not cast literal by to type timestamp. Yeah, so the problem here is that we can't, because these are different, the by column is a string, or literal, and the time.ts stamp column is a timestamp. When we try to squish them together, it's like, hey, these are two different things. They don't fit. We do get an error, and it doesn't coerce. It also might be like the R one that coerces, and that's not a SQL thing. That's a good question for research for me. All right. Question: how to overcome data skewness and unbalanced joins? Since all data with the same join key go to the same shard, this shuffling can overload the slot. Oh. Good question. I don't know. What I do know is that BigQuery in particular will scale up compute as needed to run your queries. So I think it just like adds more, I guess. I don't know. Ideally, you want to join on tables that are as small as possible to avoid problems like that. Yeah. And Kush says union returns a single column always. Nope. You can see that if I undo my example that didn't run, this union returns multiple columns. All right, let's go to the forums. Kaggle.com. Nope. Kaggle.com/learn forum. There we go. BigQuery, question by Alex. Can anyone please explain how the list row function works? Oh, sorry, I made it big. So the list row function is this one. So this just prints out a certain number of rows from the given table, and you say how many you want maximally. And I believe that, like everything, this is shuffled, so it will go and get different ones every time, unless you have a cached query. So you can treat this like, what's the Python one? iloc, I think, or head. It's probably easiest to think about it as head for a SQL table that you have a reference to. So, good cue. For Alex, let's see. Stuck on the exercise, group by having an account. We did that a while ago. Can't open notebooks. That's not so good. Let's see. And I haven't been having trouble this morning. Let's see. Let's take a look. Justin Bieber. I don't know. He was a Kaggler. Oh, so if you zoom in, that's not helping. If you open the image in a new tab, that didn't help either. Nope. Okay. Well, this header here says this kernel is powered off. Click on this banner to turn it back on. That's what will happen if you leave for a while and your session idles out. So if that happens to you, you can just click on that banner and it will power back up. So that's the simple answer. That one's an easy one to fix. It's like when your computer goes to sleep if you leave it for a while. Same thing for kernels. Kova says, I have a question in discussion regarding as and with. I have a problem with extract date. Can you please look into that? All right, let's see. 2 hours ago. Also, I don't know what happened. I did schedule the email to go out at 11 p.m. Pacific time, and I thought I set it up correctly, and it just didn't go out. And it was like 11 p.m., sorry, yesterday. It's not that I got the date wrong, because I have done that in the past. I need to actually contact Intercom and be like, yo, what's up? Beetlejuice. I'm sorry, I can't see the one that you were talking about. Amlin says, regarding the union, if we use aliases for each data set and then avoid SQL reserved words. So I think union is going to look for the same title as well. That's a good question. Yeah. Can we have some intro to R? I actually have, if you like, you're starting from nothing. I have a set of tutorials. There we go. Rachel's R tutorials that you can check out. And the first ones are like basics getting started in R. So I would start there. I don't know. Maybe we'll do a video series. We'll see. I've got to finish the summer camp first. Was it this one? Oh, yeah, there is a problem with the progress tracker. The engineering team is working on it. It should be fixed very soon. I know it's deeply frustrating. I'm frustrated. The people who are looking for the bugs are frustrating. It's just like, it's awful all around. But we're working on it. We're actively working on it. All right. We already did that one. Was it this one, maybe? Nope. We already looked at that one. It'd be great if we had you've already opened this little, like, open envelope thing. Missing value in intermediate machine learning. Sorry, that's the wrong course. Random state. How to choose the good random state. Don't choose one. Generate it randomly. Okay. Abhishek says, same column is not required, only same data type. Let's see if I can find Kovis's comment, because I think that sounds like a good question that I do want to get to. Interest equal as and with. Let's check out discussion, unranked, committing completeness. Is it this one? Extract. Okay, yeah, it looks like it's this one. So the problem is the extract clause. Found that extract takes returns int64, which I'm comparing to a string when that's why I get different results. I guess my question would be, did I guess the reason for the error correctly, or am I missing something? Is my way of writing the query bad practice or prone to hidden errors? Less than or equal to. Oh. Yeah. So I think what you need to do is actually cast this as a date. That's okay. So definitely in T-SQL, you would need to cast that as a date. I think this is going to take a while, a little bit longer than I have to dig into. Oh, okay, that's a 7. I was like, this is before and after the same date. This is just going to get you everything, or nothing rather. Yeah. So it might be something to do with the way that BigQuery is automatically parsing dates. The problem is that if it thinks it's a string, it will. it will compare it alphabetically. So you can use less than and greater than with strings, and like Apple will be less than because you go up banana because A comes before B in alphabetical order. So you can still do less than and greater than comparisons on strings, but you're going to get surprising results if you are doing dates specifically. So yeah, I'll poke into it a little bit more. All right. Thank you for joining, everybody. I hope you found this helpful. I hope you're excited to get ready and do some joins and unions. And the exercise for this, you can see I've looked at the notebook, so I've got a great start thing. The exercise for this is here, and when you click on it, it will create a notebook for you. And if you just sort of like leave and you see that gray banner, it's because it's powered down, it's sleeping, just like your computer would go to sleep if you left it for a while. All right, so work your way through the exercises. I'll be on the forums today, and then I'll see you tomorrow at the same time, and we will talk about the next lesson, which is fascinating. That doesn't seem to work. That's a bug. Noted. We'll talk about the next lesson, which is... I hope you're enjoying the anticipation growing. Analytic functions, which are super duper helpful. Again, this is something that you could do in Python. It's going to be much faster in SQL, much faster in SQL. So especially if you're working with big data that's already in a database, this will be a big time saver for you. All right, folks, I'll see you tomorrow. Enjoy camp. And even before then, I will see you on Kaggle. All right. Thanks for joining. Bye.